Okay, so we're just going to quickly cover De Morgan's laws. So there's two laws that you need to know. And what we'll do is we'll start off by just stating the laws. We'll come up with an easy way to remember them, and then we'll just prove them to show you how they work. So the first law is that A and B is equal to not A or not B. And the second law is that A or B is equal to not A and not B. So I don't know if anyone spotted or can remember the easy way of coming up with these laws, but the easiest way is that you flip the operator, so an AND becomes an OR and an OR becomes an AND. We then not the individual inputs by adding our lines above, and we also not the whole expression. So similarly here, our OR has become an AND. We've knotted the A, knotted the B, and knotted the whole expression. So flip the bits and then add the knots. So let's start off with A and B equals not A or not B. And what we'll do is we'll just prove this to show you how they're equal to each other. Okay? So let's start off with A and B. We'll use our normal 4 inputs, and we'll use the truth table method to prove this. So 0, 0, 0, 1, 1, 0, and 1, 1. First of all, let's get a result for the left-hand side of our equation, so A and B. And then we'll prove that the right-hand side of the equation is equal to that. So don't forget the AND operation. Both the inputs must be true in order for the outputs to be true. So we're going to have 0, 0, 0, 1. In order to work out the answer for the right-hand side, we're going to do it in a couple of steps. So first of all, we'll find not A and not B. Then what we'll do is we'll OR those together. And then finally, to get our answer, we will just knot that whole equation. So not A or not B. So let's start filling this in then. So not A is simply our A column, but flip the bits. 1, 1, 0, 0. And our B column, we just flip the bits to get not B. So 1, 0, 1, 0. Next column, we need to OR those two together. So we take our not A and not B, and we OR those into this column. So we're going to have 1, 1, 1, 0. Because don't forget, with the OR operator, if either or both of the inputs are true, then the output will be true. And then finally, to get our final result in our last column, we're just going to knot that. So we'll take this, apply the knot operation, to flip the bits to give us 0, 0, 0, 1. So we can see that our A and B column here and this column, based on the inputs, the results are exactly the same, and therefore A and B must be equal to not A or not B. Let's also prove the second law, that A or B is equal to not A and not B. We'll use the same method. We'll take A and B as our inputs. Same 4 possible combinations, 0, 0, 0, 1, 1, 0, and 1, 1. And we'll start off just by ORing those together to calculate the left-hand side of our equation. OR operation, if either of the inputs are true, then the output's true, so we're going to have 0, 1, 1, 1. Now we move on to the right-hand side of the equation. We're going to do not B, not A. So first of all, B, going to go into that one. So we're flipping the bits. So we're going to have B as 1, 0, 1, 0. A will be 1, 1, 0, 0. Next we'll AND those two together to give us not A and not B. So don't forget, both the inputs need to be true for an output true. 1, 0, 0, 0. And finally all we need to do then is to knot this one to give us not A and not B. So again, not just flips the bits to give us 0, 1, 1, 1. And we can see the answer for this here is the same as the answer for this. And therefore A or B and this not A and not B are equal to each other.